Welcome to today's deep dive. Today you've handed us the product specs for the Smart-AVI HDR-32x32-PLUS-S HDMI Matrix Switch, and you want us to decode it.
Yeah, it's a massive piece of commercial AV hardware.
Right, exactly. So our mission today is to figure out what this beast actually does, how it works, and, why it commands a discounted price tag of just under $9,800.
Which is a pretty penny, right?
Oh, absolutely. So to start, think of like those old black and white movies, where a telephone operator is just frantically plugging cables into a wall-sized switchboard.
Just to connect calls, yeah. The physical patching of party A to party B, it's actually a highly accurate comparison.
Right. But instead of routing static field audio, this modern switchboard is directing uncompressed 4K 30 hertz video and like 7.1 digital surround sound across massive commercial spaces.
Yeah, and doing it seamlessly. Looking at the specs you share, this is a 24.5-pound, 19-inch rack-mountable unit. It takes 32 high-def inputs, so things like satellite boxes or media servers, and it routes them to 32 outputs. In any combination, completely independently and with zero signal loss.
Which is wild.
It is. That continuous 32 by 32 cross-point routing is where the engineering really lies. I mean, you are maintaining signal integrity across a massive internal backplane, all without introducing latency.
Okay, but here's where I want to push back a little on the hardware capabilities, because looking at the spec sheet, it notes it only outputs HDMI up to 20 feet, or 40 feet if you're using high-quality active cables.
Yeah, that's true.
Wait, so if I'm building out a 32-screen sports bar or, I don't know, a casino floor, 40 feet gets me nowhere. Why is a $10,000 enterprise switch tapping out at a 40-foot radius?
Well, that isn't really a limitation of the switch's processing power. It's actually the physics of the HDMI standard itself.
Oh, really?
Yeah, pushing uncompressed 4K at 30 hertz requires handling data rates around 8.9 to 10.2 gigabits per second.
That is a lot of data.
Exactly. And when you pump that much data through copper TMDS lines, the high-frequency signals just attenuate drastically over distance.
Oh, I see. So the clock rate is basically outrunning the physical capacity of the copper. Like, the data packets just degrade before they can even reach the screen.
Precisely. Enterprise installations don't use this matrix to run cables straight to distant ceilings.
Oh, they don't?
No, they use it as a localized processing hub. It organizes the chaotic knot of 32 source inputs, then pushes the assigned outputs to secondary transmission extenders.
Oh, like HDBaseT or fiber optic balloons?
Exactly. Those are what actually cross the building.
Okay, so if the switch is locked in a localized IT closet coordinating all this traffic, that creates a logistical problem, right?
How so?
Well, you aren't walking into a dark server room with a little plastic remote control every time you need to change the game on screen 14.
Right, you aren't. Which is why the spec sheet details several industrial control interfaces. You have RS-232, which is a serial communication standard.
Right, very stable.
Incredibly stable for hardwiring the switch directly into a legacy AV control processor.
And I see it also supports TCP/IP for more modern IP-based networks. So theoretically, a bartender could hit a button on an iPad interface, and that sends a packet over the local network to instantly switch input 4 to output 28.
Exactly. That is the enterprise-grade integration you are paying for here. But, the actual heavy lifting happens without human intervention.
Right, through its EDDI management.
Yes, the extended display identification data.
Let me see if I have the mechanics of this right. When you plug a source into a monitor, there is a data exchange.
Yep, an I2C data exchange.
Right. And the display essentially sends a data structure telling the source device its specific resolution capabilities and audio formats.
Right, it says, here's what I can handle.
But with a 32 by 32 matrix, if you map one media player to 5 different screens of varying ages and resolutions, those conflicting EDI packets would crash the source, wouldn't they?
They absolutely would. It would cause a complete HTCP handshake failure.
So the screens just go black.
Yeah, the displays would just go completely black. What this Smart-AVI unit does is actively manage that data layer.
Okay.
It can clone the EDI from any connected display, store it in its own memory, and then present a unified, stable data structure back to the input sources.
Oh, wow. So instead of the source device panicking because it's receiving 5 different resolution demands simultaneously, the matrix intercepts those data structures.
Exactly.
It normalizes them and feeds the source a single digestible EDI profile.
Right. It acts as a protocol buffer. It ensures the source outputs a signal that the mapped screens can actually handle, which keeps the entire routing network flawlessly synced.
Which is incredible, and this brings it all back to you, the listener. The next time you are sitting in a mega sports bar watching 30 different games playing simultaneously without a single skipped frame, you'll know exactly what kind of heavy-duty hardware is acting as the wizard behind the curtain.
It really is a wizard. But this raises an important question for the future, though. Yeah. As our bandwidth demands grow heavier, pushing into 8K resolutions and beyond, copper cables and localized physical switches are going to face even tighter physics constraints.
Oh, for sure.
It makes you wonder how long it will be before these physical matrix boxes become obsolete relics, entirely replaced by wireless, cloud-based AV over IP routing.
Wow. From a physical 1920s telephone switchboard to a localized multi-gigabit hub to eventually floating completely in the cloud. Now that is a thought to leave you with.